Good evening, students. That is what to say you. You are still in class 10. You have not got your results, but still I can say that you are virtually in class 11. So welcome to class 11 chemistry class. Okay. So today I am going to start basic concept of chemistry. I hope you have seen the PDF which I have sent it to you in your WhatsApp group. You must see the PDF, and so that you will come to know that what we are going to do, what are the things we are going to do in this academic year, and what is my planning, and everything you will come to know. Okay, so without wasting any time, let me start the chapter. Your chapter is basic concept of chemistry, the first chapter. Now in this chapter you will see in the beginning, what we are having is that is we are having, that is, what is chemistry, what are the different branches of chemistry, like physical, organic, inorganic, biomolecular, analytical, industrial, so many other we are having it. Then we are having the states of matter, solid, liquid, gas, plasma, and all those things, difference between it. Now all these things you studied in the lower classes. What I am talking to you, all these things you studied in the lower classes. Now here you will be getting, that is nothing but precision and accuracy, and you will be getting also, that is, some numericals. Alright, upon significant figures. So that I will teach you, that I will tell you when I will be doing the numericals. Okay, that I will tell you, I will teach you. Don't think that I am going to skip all these things. I am not skipping it, but I will tell you all these things. Alright, time to time I will let you know. So when your chapter will be over, you will see everything is being taught to you. So don't worry about it. Okay. So now today I am going to start. That is nothing but the laws of chemical combination. What I said, the laws of chemical combination. The laws of chemical combination. Let me write clearly. Laws of chemical combination. Okay, from there I am going to start. Now, in the laws of chemical combination, you are having 5 laws. You are having 5 laws. The first is your law of conservation of mass, which was given by Anthony Lavoisier. You must be knowing Anthony Lavoisier is being considered the father of modern chemistry. Okay. The second law is the law of definite proportion, or the law of constant composition, which was given by J.L. Proust or Joseph Louis Proust. I hope, children, you are following, you are able to understand what I am speaking to you. Now the third law is the law of multiple proportion, which was given by John Dalton, the third law. The fourth law is the law of reciprocal proportion, which was given by Richter, R-I-C-H-T-E-R, Richter, we can say that. And the fifth law, ICSE student, they have studied, that is Gay-Lussac's law of gaseous volumes. Gay-Lussac's law of gaseous volumes, we can say that. Of course, when I say Gay-Lussac's law, it is given by Gay-Lussac only. So these are the 5 laws of chemical combination we are having it. So we are going to study one by one. So first we will take the law of conservation of mass, which was given by Anthony Lavoisier. What I said, the first law is the law of conservation of mass. Now, what is the definition of this particular law? First, I will say the definition. Of course, you see, children, I will be sending you the PDF. That is a PDF which will contain all my notes, which I am saying you now. All this you will find in my PDF. In my notes, you will be getting it. In my notes, you will see the PDF which I will be sending you. You will see, initially you will be getting the notes. Then after that, you will get some important question. Alright. Then after that, you will be getting the practice paper, the chapter test. You will be getting one by one. Okay. So after each and every class, I will be telling you that these are the questions you are supposed to do from the PDF. And of course, you have to do the questions from your book, that is NCERT, the CBSE children, got it? And the ISC children, either you will follow Kail-Chugh or Nutan chemistry, we can say that. Okay. So for that reason, I have written in my PDF, which I have sent it to you already, that the NCERT PDF I am going to send it to you. You can also do the questions from there. No need to worry, ISC children. I have written it there. Again, I repeat, no need to worry about it. You can do the questions from NCERT. Okay, fine. Now, next is That is the law of conservation of mass. What is the definition? Got it? I am saying it slowly, you may write it down also. Now this law is in accordance with the law of conservation of energy. It is in accordance with the law of conservation of energy. Now what is law of conservation of energy? It states that in a particular chemical reaction, total energy remains constant. It can only be converted from one form to another form. Similarly, the law of conservation of mass states that in any physical or chemical change, the total mass of the reactants before the reaction is equal to the total mass of the product at the end of the reaction. Again I repeat, in any physical or chemical change, the total mass of the reactants before the reaction is equal to the total mass of the product at the end of the reaction. Now, to explain this particular one, I am taking an example. I said the total mass of the reactants. Now, a very simple example I am taking for you. Now, you in the lab you might have done it. That is, you have taken magnesium ribbon and you have burnt it in air. What you got? You got residue, that is a white residue, which is nothing but magnesium oxide, so to say. Alright. So, what is the reaction I said? Magnesium, it is burnt in air. Alright, to give you, that is nothing but 2MgO. The reaction has to be balanced always. Now, I have to prove it that it obeys the law of conservation of mass. Now, how to do so? Very simple. Now, the atomic mass of magnesium is 24. So, 2 into 24. Oxygen, it is 16 into 2. The atomic weight of oxygen is 16. 16 into 2 is 32. So, how much you got? 48 plus 32. So, 8 to 10, 4 3 7 1 8. So, total weight of the reactant, how much you got it as? 80 gram, let us say. Now, for magnesium oxide, we'll see. Magnesium is how much it is? Nothing but 24. Oxygen is how much it is? 16. 24 plus 16, how much it is? Nothing but 40. 40 into 2, how much you get it? 80 gram. This is what? Total weight of product. Now, what I said you? In any physical or chemical change, the total weight of the reactant is equal to the total weight of the product. You can say 80 gram at the end of the reaction. You can see. In this way, it's a simple example I have given you, which you have done it in the lab. Definitely you might have done it in the lab, this particular one. You have taken a magnesium ribbon and you have burnt it. You got a dazzling white light and you got a white residue. In this way, you can take another example also and you can see it. Hydrogen plus oxygen, 2H2 plus O2 will give you 2H2O. In this way, you can take it. Any example, you can take it and you can see it. NaOH plus HCl will give you NaCl and water. Any example. You will find the total weight of the reactant is always equal to the total weight of the product at the end of the reaction. Now, this law was given by Lavoisier. Okay. Now, we'll have the experimental verification of this law. Now, this is just an example I have given you. Now, we'll have the experimental verification of this law. I am rubbing it. So, experimentally, it was not verified by rather Lavoisier. It was verified by Landolt. Got it? So, what I said? Landolt. Landolt apostrophe S. So, I am going to do it now. The Landolt's experiment. What I said you, we are going to do the experimental verification. So, Landolt, what he did is that he took a H-shaped tube, a glass tube. We can say that. A glass tube, you can see, I am drawing it here, which is H-shaped. Alright, you can see it here. The glass tube which is H-shaped. Okay. Now, this is also called as H-tube or it is also known as Landolt's tube. Fine. Now, here you can see two limbs are there. Now, what will I do is that I will open this. There is an opening here. An opening is there. Alright, just a cork or whatever you can say it is there. You'll open it and in this limb you'll add, that is nothing but, let us say, silver nitrate solution. You'll add it to it in this limb. And in this limb, what you are going to do is that you add sodium chloride, NaCl solution, you add it. Now what you do is that you close this cap. Alright? Don't disturb it. Just close the cap. Alright? And what it is that when you close the cap, there might be some air holes, isn't it? So you just put some Vaseline or you put some wax around it. Alright, you put some Vaseline or you put some wax around it so that no air holes should be present in it. Now, if air holes will be there, what will happen? There might be some, what you can say, convection, or there might be some convection only, I can say that. That is, convection means what happens is that is due to the air hole, some energy may go out, or some energy may come in also. Alright, so as to prevent that, so as to see that no energy is going in or coming out, alright, or any mass or anything, we have closed the air holes to make it airtight. That's it. Fine. Now what you do is that you have closed the cap, you have just with the wax or the Vaseline. Now what you do is that you turn it upside down. You turn it upside down. When you turn it upside down, what you will see, this reaction is going to take place. AgNO3 reacts with NaCl to form AgCl, which is a white PPT. This is a white PPT, AgCl, plus NaNO3. You will be getting it. What I said, AgCl, a white PPT. So when you turn upside down, you will get a white PPT. Once you get the white PPT, you just wait for some time for the reaction to get completed. Once the reaction has got completed, what you do is that you wait. Now, before that, I forgot to tell you that before starting the experiment, you weigh this apparatus. Before starting the experiment, you weigh the apparatus. Alright, before starting. Clear? After adding AgNO3 and NaCl, you weigh the apparatus. So let us say the weight comes to be as 500 gram. What I said you, this is weight of reactant. 500 gram before the reaction. Before starting the experiment, you have done it. Now, after the reaction has taken place, you have got white PPT and the reaction has subsided, the reaction has settled down. Again, you take the weight along with this glass tube, of course. Along with the glass tube, I got the weight as 500 gram. Again, you take the weight along with the glass tube. You will find that the weight of the product is 499.99 gram. It is almost equivalent to 500 gram. We can say that. Now, what does it prove? It proves that the total weight of the reactant before the reaction is equal to the total weight of the product at the end of the reaction. Total weight of the reactant before the reaction was how much? 500. And total weight of the product at the end of the reaction is how much it is? 499.99. We can consider it to be as 500 grams. So, from this experiment, from this Landauer's experiment, it has been verified that the total weight of the reactant is equal to that of the product. Thank you very much.